with this equation, it's going to be 4/3 pi times r times r times r. And so our uncertainty, which was great, thank you, 0.02. I defined since we're multiplying, the first thing we have to do is get the relative uncertainty. So the relative uncertainty is the percentage, and so our first step is going to be 0.02 divided by 51.3. And what does that give us? Okay, let's multiply it by 3 now. So 0.00, what is it again? 11696. Okay, so this is the decimal value of the relative uncertainty of the percentage. Now, to get the actual relative uncertainty, we simply have to convert this into a percentage. So we're going to multiply by 100, which gives us 0.11696%, or we can just round that up to 0.12%. So this is our relative uncertainty for this particular problem.
Why 0.12? Why not 1.117? There's 3.
0.117 would be fine.
Okay. Is Schoology thing going to take it?
No, it'll take 0.12. Well, and realistically, if we're getting into the reason it's 0.12 is because you can only keep it as the least number of significant figures, and since 0.02 has 2 significant figures, ultimately you're only going to have 2 significant figures in the answer. So technically that's why it's going to be 0.12 instead of 0.117. But again, 0.17, you're getting the calculations correct and you've got the right idea there. Now, the second part is to find the absolute uncertainty. And to find the absolute uncertainty, we have to actually calculate the volume of our sphere. And so that's going to be 4/3 times pi times 51.3 cubed. And that gives us a volume of what? $565,000. What was the rest of it? 510.5 cubic centimeters. Okay, we always make sure we add our units in there. And so this is our volume, plus or minus 0.12%. Okay, now we simply have to convert our percentage to an actual absolute value. Thomas?
Wouldn't you have the uncertainty inside 51.3 cubed rather than the whole thing?
What do you mean?
Because uncertainty is only for the length of the centimeters part. Or is it uncertainty for the whole entire equation?
Which one? The plus or minus 0.02 is just for the radius, but the 0.12% is for the final volume.
Oh, okay. So you also put in the pi and 4/3 part.
Right. Well, and 4/3 and pi are absolute numbers, So there's no uncertainty in those numbers.
So wouldn't uncertainty only be for the 51.3 cubed part?
Yes.
So why would you do it after you make the equation number 5?
Well, because this is the actual volume. Just because we're multiplying these in doesn't mean the uncertainty goes away. The uncertainty, the plus or minus 0.02, applies to this 51.3 each of the 3 times. And so that's why we, over here, calculated the 0.0011696 as the relative uncertainty. That's the relative uncertainty of the entire volume after the calculations. Does that make sense? You sure?
What? I'll
Well, this is the percent uncertainty in the total volume. Now, that uncertainty only comes from the measurement of radius. There's no uncertainty in these two, but what we could just as easily do is, let's see if this is going to work. The uncertainty is actually going to be 0.001169 plus 0.00169 plus 0.00169 plus 0 plus 0. This is R, the 4/3, and the pi. And so we are adding the uncertainties of all 5 parts of the equation.
Those are just constants that don't have to.
Exactly. Okay? Okay, so 565,510.5. Come on, give me another slide here. How do we go from a percentage to the actual? James?
Multiply the 56551 times 0.0011695.
Right, because we have to convert from the... What is going on with this thing? There we go. So 565,510.5. We convert that decimal or that percentage into a decimal. So we're going to multiply by 0.0012. And what does that give us?
Do you want to use the 1, 2, or the...
Either one. We'll get to the general.
661.4.
Okay, so 661.
Oh, wait. All right, yeah.
Okay, 0.4. Okay, close enough for our purposes here.
Using the 0.12, you get a different answer than like the actual.
A little bit higher, right?
Yeah.
Yeah, and that's okay. So our final answer for volume, whoops, too many 5s, 10.5 plus or minus 661.4 centimeters cubed.
Is that how many sig figs there should be, or should there only be 661? Because the
Right, and the actual, if we're gonna be appropriate with our sig figs for the uncertainty, it should really probably only be 3,
okay.
um,
What should
or actually even 2,
what should I bring it to?
whatever your gut tells you. And I'll take a look at it, and if you're right, if you're putting this in and it marks it wrong, I'll change it. It's not a big deal. Okay, so but in terms of the process, this is how you work through it. Are there any questions?